2013 Civil Engineering Question 50. For a portion of national highway where a descending gradient of 1 in 25 meets with an ascending gradient of 1 in 20, a valley curve needs to be designed for a vehicle traveling at 90 km per hour based on the following conditions. Headlight side distance equal to the stopping side distance of a level terrain considering the length of valley curve greater than the stopping side distance. Comfort condition with allowable rate of change of centrifugal acceleration which is given as 0.5 meter per second cube. Assume total reaction time as 2.5 seconds, coefficient of longitudinal friction of the pavement as 0.35, height of the headlight of the vehicle as 0.75 meters and the beam angle as 1 degree. So what is the length of the valley curve based on the headlight side distance condition? The relevant NPTEL reference has been listed. Coming to the useful data, if we have been given a valley curve where the gradient is changing from minus n1% which is a descending gradient to a positive gradient of plus n2%, the change in gradient is given as minus n1 minus of n2 which can be given as minus n1 plus n2. So the magnitude of the change can be taken as the positive of this, that would be n1 plus n2. So the length of the valley curve is designed by using two conditions. The first condition is when the length is greater than the stopping side distance. In this case, the length of the valley curve is given as ns square divided by 1.5 plus 0.035 s. Here s is given as the stopping side distance. Other case is when the length of valley curve is less than the stopping side distance. In this case it is given as 2s minus 1.5 plus 0.035 s divided by n. So by finding the SST, one can calculate the length of valley curve depending upon the assumption that either it is greater than SST or it is less than SST. In this case, the first gradient is given as 1 in 25. So in percentage it can be calculated by dividing it by 100, which would give the answer as 4%. The second gradient is given as 1 in 20. So this would be 100 over 20, that is 5%. So the magnitude of change is given as n1 plus n2, that would become as 9%. Here I have neglected the signs as we are going to add them irrespective of their signs. The V value is given as 90 kilometers per hour. This can be converted into meter per second by operating it with 5 by 18, which would give the value as 25 meters per second. Now it is mentioned in the problem statement that the length of the valley curve is greater than SST. So the equation that would be utilized is ns square divided by 1.5 plus 0.035 s. Now we need to find the value of s. So s is given as Vt plus v square by 2gf, which is the stopping side distance. So the value of v is 25. T is given in the problem as 2.5 second and the value of longitudinal friction is mentioned at 0.35. So 25 into 2.5 plus 25 square divided by 2 into g, that would be 9.81 into f value, that is 0.35. The value would turn out to be 153.66 meters. Substituting this back in the valley curve equation, so n was found out as 9%, so that will be taken in decimals into the SST, that is 153.66 square divided by 1.5 plus 0.035 into 153.66. The value would turn out to be 308.97 meters, which is the length of the valley curve, assuming that it is greater than the stopping side distance. So the length of the valley curve based on the headlight side distance criterion was found out as 308.97 meters. The relevant NPTEL reference has been listed.